we are talking about coordinate geometry. Now, coordinate geometry is kind of like what it sounds. It's geometry, but with a coordinate plane. So what is a coordinate plane? Alex?
Those like grid thingies, like the numbers and stuff, like the little dots.
So it's your coordinate grid. It's your x, y axis. You have your points. You have your Cartesian coordinates instead of coordinates. Like everything we did last year in algebra, graphing, all that fun stuff. Yeah, that's all. Those are all coordinate grids. So coordinate geometry. It's basically we're taking both of them and we're blending it together. We're taking what we've learned with graphing. We're taking what we learned with determining something on a coordinate grid. And we're taking what we know with geometry. And we're trying to solve things together. So this might look into how to find the perimeter of a shape, how to find the area of a shape, how to determine what type of shape it is, based off of what information we can discern from this graph. And so that's what we're going to be talking about this week. So we're just practicing coordinate geometry, practicing how we can use what we learned already, which is sort of 2D stuff, and how to put it in on a coordinate grid and how to implement them together. So the first thing we're going to focus on this week is perimeter. So what is the perimeter of the shape?
The outside.
It's the length of the outside. So if you're to find the perimeter of this triangle, what do you have to do?
Add all the sides together.
Add all the sides together. So that's 17 plus 23 plus 12. Add all that together, and that gives you like 52. And so 52 units, or 52, whatever the measurement would be, that would be your perimeter of your triangle. So pretty simple, pretty easy, very generic. Coordinate geometry, we just talked about that. So basically, if we take this perimeter and we switch it into coordinate geometry, how would you find the perimeter of that first rectangle?
Count the things.
Count the things. What are the things?
Boxes, the square thing.
Count your sides. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 for that first one. And I can do the same for my other side. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just by looking at this, I know it's a rectangle. Without having to prove anything, we see our right angles, we see our equal sides. So it's a rectangle. So we know our other sides would have to be the same. This is 9. This is also 14. From here, we can just add all these numbers together, and that gives us our value. So that's 9 plus 14 plus 9 plus 14. Add all that together, I think we get 46 figure. Yeah. And so 46 would be your value. So pretty simple, counting sides, figuring out what that is. See if you can get that second one on your own. See if you can count what your sides are, figure out your total perimeter for that second rectangle we have. So what did we find for our missing sides? What did we count on? 5 and 10. That's 5, 10, 5, 10. We add all that together. What does that give us? 30. So 30 units, 30 segments, or whatever you want to determine. And the value would be your perimeter. So very simple, very easy. You're just counting sides pretty much at this point. Look at this triangle. So we have this triangle. We want to find the perimeter of this shape. How would we go about this? What would you do? What can we do? What do you mean?
Find your slope of the line thing.
The slope of my line determines how my line is oriented. Doesn't necessarily tell me a length of it though. Because we can't, with this diagonal line, we can count my other sides. I can count this side as 5 and this side is 8. If I know that, but with a diagonal line, I can't count that directly. I can't count the squares of a diagonal line because I don't know if this is one square, or if that's a corner of a square, or if that's half a square. Or I don't know what these measurements are.
Oh, is this something?
What type of triangle is this? Right. Find the missing side of our triangle.
Pythagorean theorem.
Pythagorean theorem.
Okay.
That's my a squared plus b squared equals c squared. Now, which side am I looking for? A, B, or C?
C.
C. Why do you know it's C?
But it's the curve on line. It's opposite.
So our hypotenuse, our longest side opposite of that 90-degree angle, that's always C with your Pythagorean theorem. They'll always be on that side by itself. So with this, we can just fill in our values. That's A squared, which is 5 squared, plus B squared, which is 8 squared, plus, equals C squared. 5 squared, we can fill these in as 25, plus 8 squared is 64, equals C squared. 25 plus 64 gives you 89. And here is where it gets a little tricky. We have to think, how do I get rid of that square? Square root. Inverse operation of a square is a square root. Then, square root of 89. The 89 doesn't have a perfect square. So with this, you'll have to put it in your calculator. It's going to give you a decimal and walk around a little bit. It should come out to be 9.43, somewhere right around there. How you round. And so we get that length that has 9. But from here, now we have all 3 of our side lengths, and now we can add them together. So 5 plus 8 plus 9 plus 4, 3. And that would be our perimeter. Or a very close estimation of your perimeter due to our rounding. So, if you have a diagonal side line, or something like this, you can't just count it directly. You can't just point and look at what this is going to be. So with those diagonal side lines, we will have to use this method. You will have to use the Pythagorean theorem or something else to be able to figure out what is that side line. How can we do it? You can't just count them. Is there any other way we could think about solving this besides using the Pythagorean theorem? Distance thing. What's the distance thing?
You find the distance from like your two points, like the ends of your line. That'll be able to.
So if you think about their side length, it's 2 points. So this point up here, which is negative 5, 2, and then our other point, 3, negative 3. Now distance formula, we can use that to find the distance between 2 points. That will give us the length of this side. If you think about it, thinking about the distance formula that we learned back in September, it's derived from the Pythagorean theorem. So it's same steps, same ideas, just written down a little bit differently. How does the distance formula go again? All under square root. So, distance formula was the square root of your difference between your x's, so x2 minus x1 squared, and then the difference between your y, so y2 minus y1 squared. Both those values squared, add them together, take the square root of that, and what's your distance between 2 points. And so this is what we did back in September, August, right around that time. It would have been like right at the end of August, beginning of September. We were using this formula to find the distance between 2 points. So, just as and I hear these examples work. So the Pythagorean theorem gave us the distance formula. The Pythagorean theorem is derived from the distance formula is derived from the Pythagorean theorem. It uses the same steps, same idea, same properties. So you can use either method for finding a side line. Boys, for those of you who just popped in, what we're talking about today is we're talking about perimeter and finding the perimeter of a shape through coordinate geometry. So coordinate geometry is just when you're using geometry on coordinate grids, so like x, y axes, you have points plotted, not plotted. And so with perimeter, we're looking for all those side lengths. But the thing is, so most of the side lengths we can just count normally, just by looking at what is the length of it, like 1, 2, 3, 4, 5, that's 14, 9, I can add all those together, I can get my perimeter pretty quickly. The issue we ran into, though, was if you have a diagonal side, because you can't just count that directly. You can't just count that, because you get some of those squares aren't full squares, so I don't know what the full distance is. But what we talked about is, well, this makes a triangle. It's a right triangle. So in order to find that missing side, I can use Pythagorean theorem. A squared plus b squared equals my c squared, which is my missing side. So I can use that to find my missing side. We just actually talked about that. This was one method to solve. Another method was, as long as you know the coordinates to both those points, we can use our distance formula that we talked about at the beginning of the year. So back in September when we learned about distance formula, midpoint formula, slope, things like that. We're using this to find the distance. And so as long as you have two coordinates, you can find the distance formula. So if we were to do this example with 7, 10, and 12, -2, we can say our distance is equal to the difference between our x's. So x2 is 12, and minus x1, which is 7. We can square that value. And then we can do the difference between our y. So y2 is -2, minus 10 as 1 y1 squared. So what would you do first?
Do your stuff in your parentheses.
And then parentheses. So 12 minus 7 gives me 5 squared. -2 minus 10. So -2's already in the negative direction. I'm subtracting another 10. So I'm continuing in the negative direction. Gives me -12 squared. It's important to put that negative inside the parenthesis because if we think about it, what is -12 squared? What is that value equal? 144. Why is it not negative 144?
Because when two negatives are multiplied by each other, it makes a positive.
So a negative times a negative is a positive. So a negative squared is still a positive number. But if you just put -12 squared in your calculator without those parentheses, your calculator is going to see that negative outside, and it's going to square 12, which will give you 144, and then it'll make it a negative 144. So anytime you're putting a negative in your calculator, just make sure you're squaring that with the parentheses in there, so it doesn't mess up. So you should always get a positive number, even if you're squaring. From here, 25 plus 144, we can do this pretty simply. Add those together, we get 169. And then square root of 169, we might know that. That gives us 13. With this, we got our answer. So either of these methods work. Pythagorean theorem or distance formula can both work for finding the sides of like a diagonal length. It's really just preference. Some people prefer distance formula. Some people prefer Pythagorean theorem. I'm more of a Pythagorean theorem person, but I know a lot of people like distance formula. I think Mrs. Ruprecht is more of a distance formula person. So it doesn't matter which one you prefer. I just want you to be able to do either method. So given a thing, can you find the distance? Sure. Use Pythagorean theorem? Sure. Use distance formula. Whatever one works. Some situations might mean better to use a certain formula compared to another, but that doesn't mean it needs to restrict you to that formula. So let's see some examples. So we have this triangle here. We want to determine whether this is an equilateral, scalene, or isosceles triangle. What do those words mean for triangles? What are some of those? Out.
The equilateral triangles are like all three sides of the same side.
So equilateral triangles have all three sides of the same. Okay. What's this isosceles triangle? Not an isosceles triangle. There can't be. It's possible to have an isosceles triangle, right? Isosceles triangles means two of the sides are the same. So equilateral is three congruent sides.
Does this go back to square?
Say that one more time.
Like, you know how like the square, is that kind of like what this is, but a triangle?
Kind of. These are more just sort of like equilateral triangles have special properties. Isosceles triangles have certain properties. Scalene, it's just three different terminologies we can count a triangle under. So isosceles has two congruent sides. It's not necessarily as defining as a rhombus compared to a rectangle. It kind of is, and kind of not. It's not as important as like if it's a rhombus to a square compared to like an isosceles. So scalene is 0 congruent sides. So equilateral triangles have three of the same sides, so three sides are all the same length. Isosceles triangles have two sides of the same length, and equilateral triangles, all the sides are different lengths. So we want to determine whether this is equilateral, scalene, or isosceles. So in order to do that, we're going to have to figure out what all three of the sides are, and just look how many of them are the same. So once again, we have two methods. We have the Pythagorean theorem method we can do, or we have distance formula. We're going to do two together, and then I'll let you do the last one on your own, depending on whichever one you prefer. So we'll start with Pythagorean theorem. So with this, for Pythagorean theorem, you just need to draw your right triangle. So say I want to find the distance between these 2 points right here. My right triangle, I just need to go vertical and then horizontal, because I know those methods, I know those distances, I can count those, and then I can use Pythagorean theorem to find my 6 sides. So let's see, if I look down, that's 1, 2, 3, 4, 5, what was that? 9, okay. And then my other side should be 5. So I know my 2 sides for my a squared plus b squared equals c squared is 9 and 5. So a squared plus b squared equals c squared. I can just fill those in with 9 squared plus 5 squared equals c squared.
That's not telling me what these are.
Right. So it's only going to give you one side. I'm going to have to do this 3 times to be able to figure out all my sides. So we're going to do 2 together, and then I'm going to give the last. I'm going to let you do the last one on your own. So yeah. So that's the thing. Looking for the perimeter or looking for side lengths can be kind of tedious because you might have to do it multiple times. But 9 squared, we know what this is. That's 81. 5 squared is 25. So 9 squared, or sorry, 81 plus 25 gives us 106. And now I want to take the square root of 106. So the square root of 106, once again, that's not going to be a perfect square, so that should give us, I'll have to use our calculator, but it should give us 10.29. That was your length of your missing side. That's one side length. But once again, in order to figure out whether it's equilateral, isosceles, or scalene, we have to know all 3 side lengths to determine how many of them are equal to each other. So that's one method you can do. We could also do distance formula, like we talked about on the last page. So if I want to determine the distance between those 2 green dots, first thing I need to do is I need to figure out what their coordinates are. So this is -3, 5, and this one is 6, 4. Let's go down here. I know it has -3, 5, and then 6, 4, my 2 points. So our distance formula, we have to do this distance is equal to the square root, and then what would we put on the inside of this? How would we fill this out?
Do we have to use this in formula? It's just too messy.
You don't have to do this form. You can use whatever method you prefer. If you prefer Pythagorean theorem, you can go for it. I just want to give you an example of both. So we're going to start with our x's, typically. So 4 and 5 are our y's. So that will be our next value. So that'll be our y2 minus y1. So 6 and -3. Now, if we were to do this, 6 minus -3, so we're subtracting by a negative, so we can change it to a positive. So that gives us 9 squared. And then 4 minus 5 is -1 squared. Nine squared is 81. -1 squared is just 1. And then that gives us 80. Plug 82 in your calculator. Gets more.
Can I calculate?
Yeah. We plug 82 into the calculator. That should give us, what's that? 9.06-ish. 9 point something. Really close to 9. And that is my other side. So once again, we have 2 methods for a reason. So you can use either method. I'm not subjecting you to one or the other, as long as you can find those side lengths. So this will be 9.06. So based off of our knowledge already, we know it can't be equilateral because two of our sides aren't the same, but it could possibly be scalene or isosceles, depending on what that third side is. So see if you can find the last answer for that third side and see if you can determine what actually type of triangle this will be. Are you good with it? All right, so what did we find for that missing side length? 8.94 something something, continue on, or depending on how you round it. So once again, you can use any method. You can use Pythagorean theorem, or you can use the distance formula. I don't care which method you use as long as you can find it. So what type of triangle would we have then? Scalene. None of our sides are the same, so all sides are different. So that's a scalene triangle. Good. All right, so we're gonna look at this scary problem. So it has a lot of words. It has a lot of information being thrown at it, so it's a little bit to swallow. So let's try to analyze it and let's try to figure out what it says. So a person wants to put a fence around their unusually shaped property. The person puts a stake to mark the four corners that the property has. So we know it's going to have four sides to it. It has four corners. Standing at a central location, the person has measurements towards each stake, so they know how far away they are from each stake. So the first one is 15 yards east and 12 yards north. Then we have 17 yards east and 11 south, 7 yards west and 7 south, and then 14 yards west and 8 north.
Okay.
And we want to find the perimeter of this person's property. So, with this, we don't have a grid, we don't have like a picture, we don't have really any sort of visual. How can we go about this? What can we do to help us?
Draw it.
Draw it? Okay, how do you want to draw it?
Should you like mark your central location first?
How so?
Like put a circle to show like where you're gonna be coming from.
Okay.
So, is it central location? I don't know.
What was that?
Central location.
Just like an area close toward the middle, not necessarily directly in the middle of the shape. Because if you look, some of these are a little bit farther away. So this one's 7 yards west and 7 yards south. Well, this one's 15 yards east and 12 yards north. So it's already farther.
So how do we measure?
How do we know which direction we're going?
East, north, so like 15 yards east, and then
Oh, we learned this lesson. What is it? Because it was like, what's from the eyes and
it's a compass. But also, is it going to be grid?
No, west is not down there. I'm sorry. That is south. I promise it. All right, so we have our compass. We have northeast, southwest. With this, we can kind of think of it as a grid, as a Cartesian coordinate. But we consider ourselves at 0, 0. We can think of how far we're moving to each of these points, and then from there we can use our distance formula, or we can use our Pythagorean theorem. Now that we get a visual, we just have to think of what these points are going to be. So 15 east, 12 north. That's my first one. So 15 east is going to be somewhere over here, and 12 north is over here.
Oh, well.
So 15. Well, I know they're both going to be positive numbers because every number in this first quadrant is going to be positive. Positive in the x, positive in the y. If I think about that next one, it's 17 yards east, 11 south. So 17 yards east and 11 south is going to put me down here. I know it's going to be positive in the x, so that's a positive 17. But because I went down south, I went in the negative direction of my y. That's a negative 11. So even though it's a positive direction, thinking of where this is as a coordinate grid is still a negative. We have 7 yards west and 7 yards south. So 7 west is somewhere. And once again, these are all estimations on where I assume there would be on the graph. I obviously don't have any tick marks or anything like that. But it's just giving us an idea of what this property is. So that's a negative 7 because I went west. So I went in the negative x, and then I went also in the negative 1. Negative 7. And my last point is, let's see, 14 yards west, 8 north. So 14 yards west is somewhere over here, 8 north. We'll say here. That's 14, that is negative 14, I'm sorry, we want in the negative x, and then 8, we want in the positive y. So we have these 4 side lengths, or we have these 4 points, cornered. We can connect them to get this weird looking quadrilateral we got going on. Once again, this is just an average, or this is just an estimation. The picture is just to help us visualize it. It's not perfect, completely accurate, but it's just help us get those ideas of where those points actually are. From here, if we were trying to find this person's perimeter of their property, easiest thing would probably be doing this in formula. We have all the coordinates, we have the values, it would just be quite a few distance formulas, and then we'd be able to get it done. But if you're not a fan of the distance formula, it doesn't mean you can't use Pythagorean theorem. If you like Pythagorean theorem, you can still use it. It just might take us a little bit extra thinking. That's fine, do your distance formula. But if you want to do Pythagorean theorem, we can still draw those triangles. And just, we'll have to think about those side lengths. Because rather than counting the side lengths like we did on those last problems, we'll actually have to think about what they are. So if we think about it, I have to figure out what this horizontal or this vertical side of it is. I'm going from 8 all the way down to negative 7. So how much of a change is that? How much of a change in my y? From 8 to negative 7. Which is good. So 15. So if we're going 8 down, we're starting to 8. We go a whole 8 spaces down to 0. Then we'll have to go a negative 7, or another 7 spaces down to negative 7, which will give us a total of 15 movement. So we know that vertical distance is 15. Then the same idea, from negative 14 all the way over to positive, or negative 7. So negative 14, negative 7, we're moving 7 spaces over to get there. So we have our 2 side lengths of 15 and 7. So you can still use Pythagorean theorem on this, even though you don't have that grid to count your spaces. You just have to think about those side lengths a little bit more than what you would have before. Or you can use distance formula, because you have your coordinates already. So once again, either of these methods work. Either of them will give you the correct answer. It's just which method you prefer in which situation. So see if you can do a little practice. See if you can find these missing ones, and see how much you come up with. You might not get all the way through it. That's perfectly fine. But see if you can find 1 or 2 or 3 of these side lengths.